Hello guys, so these are the answers that I have marked for week 6 assessment 6. Okay, so this question I was not able to solve it. Still I am not able to solve it. If I will solve this question, if I get the answer, then I will post one more video before Wednesday and I will share it with you. However, I have marked A as an option. Okay, rest of the other options I have the solutions for that. Okay, so these are the options that I have marked. Okay, so now I will share you the solutions. Okay, so moving to the first question. Suppose a neural network has three input nodes A, B, C. There are two neurons X and Y. X equal to A plus B and Y is equals to X into C. What is the gradient of Y with respect to A, B and C? Assume A, B, C is equals to 6, minus 1, 4, minus 4. Okay, so here are the input nodes A, B, C. Here are the neurons X, Y. Okay, and we have to find the gradient of Y with respect to A, B, C. Okay, so we have to find it in this way: del Y by del A, comma del Y by del B, comma del Y by del C. In this way. Okay, so this is a partial derivative. Okay, so what will actually happen is this. Okay, one more thing, that when I put the value of X over here, so Y is equals to A plus B into C. Okay, now for example, if I am doing del Y by del A, so I will take Y as a variable and B and C will be constant. Okay, so this is the meaning of partial derivative. So in this way we will solve. So del Y by del A we will get C. Okay, and del Y by del B we will get C, and del Y by del C we will get A plus B. Okay, in this way. Now we will put the value. So del Y by del A is equals to C, so minus 4. Del Y by del B is also C, so minus 4 once again. And then del Y by del C is equals to A plus B, which means 6 minus 1, 5. So the total will be minus 4, and then 5, so C option. Okay, in the next question it is asking that Y is equals to max of A comma B, and it is given that A is greater than B. What is the value of derivative of Y with respect to derivative of B, derivative of A and derivative of Y with respect to derivative of B? Okay, now we have given that Y is equals to max of A comma B, and we can expand it in this format, that Y will be equivalent to A if A is greater than B, and Y will be equivalent to B if A is smaller than B. Okay, but in the question it is given that A is greater than B, so we can straight away write that Y is equals to A in all the test cases. Okay, in all the given cases. So we will do the derivative dy by dA, so it will be 1. Okay, and dy by dB, over here it should be B. Okay, so dy by dB will be 0 because B is not there. Okay, and in this way, so the answer will be 1 comma 0, A option. Okay, now in this question it is asking that PCA reduces the dimension by finding a few fill in the blanks. Okay, and the options are hexagonal linear combination, orthogonal linear combination, octagonal linear combination, pentagonal linear combination. Okay, so over here actually option A, C and D are meaningless. Like there is nothing called hexagonal linear combination, octagonal, pentagonal. This is just to confuse us. Actually the answer will be orthogonal linear combination. Okay, so what is PCA? PCA is a principal component analysis. Okay, it is used to shrink the matrices that we already have, matrices of data that we already have. Okay, and it is given in the video lecture 30 at this time interface, that the PCA is a linear transformation. Okay, and When the covariance of matrix is symmetric, then eigenvectors are taken, and eigenvectors are orthogonal to each other, which means that all the eigenvectors that are being created now, all of them are perpendicular to one another. Okay, so orthogonal linear combination will be the correct answer. Okay, the next one, I I was not able to solve this question, and I did this attempt. If anyone is interested, he or she can uh, discuss with me regarding to this. Okay, and in question 5, it is asking which of the following is false for PCA and autoencoders. Okay, so first option is both PCA and autoencoders can be used for dimensionality reduction. Yes, both PCA and autoencoders are used for dimensionality reduction, and in autoencoders it is using unsupervised approach in order to reduce the dimensionality. Okay, in PCA it is using eigenvectors and eigenvalues properties in order to reduce the dimensionality. Okay, now in the option B, it is asking that PCA works well with non-linear data but autoencoders are best suited for linear data. Actually it is opposite. PCA works well with linear data, and autoencoders are best suited for non-linear data. How? When autoencoders are using more than one hidden layer na, then it will behave like a non-linear function, non-linear contraction. Okay, in PCA we cannot like add hidden layers because it is a mathematical approach. Okay, so and also in the third question you have seen that I mentioned that orthogonal linear combination, so it it is obvious that it will work upon the linear data. Okay, okay, in question 6, what is true regarding to backpropagation rule? Okay, it is asking, it is a feed forward neural network. No, because it is backpropagation. We actually do feed forward neural network first, and then we move back, which is called backpropagation, in order to change the parameters or upgrade the parameters. Okay, gradient of the final layer of weights being calculated first, and the gradient of the first layer of weights being calculated last. Yeah, this is the correct option because it moves in the backward way na, so it will first go to outer layer, then hidden layer, then inner layer. Okay, so input layer, it should be input layer over here. So in this way the backpropagation happens. So what will happen is that it will first uh, upgrade the parameters that are present in the outermost layer. Okay, between the outermost layer and the last hidden layer, then inside the hidden layers, and then it will go to in between the internal layers and not the internal layers, input layers and the first hidden layer. Okay, C option is hidden layers is not important, only meant for supporting input and output layer. I guess it is obvious that it is false, so I will move forward. Which of the following is true for PCA? Tick all the options that are correct. Okay, so option A shows that it rotates the axis of line along with the principal components. Yes, for this I will show you one more video. Over here also you can see that sorry, over here also you can see that the original coordinate was this. Okay, and then two principal components were being found, E1 and E2. Okay, using the PCA formula. After that the origin is also shifted and the axis is also rotated, so it will shift in such a way that E1 is perpendicular and E2 is perpendicular vertical and E1 is horizontal. In this way the whole plane wave shift, so the image will also rotate in clockwise direction. Now in B option, it is saying that is it PCA is calculated from covariance matrix. Yes, covariant matrix is used, and in the first video he said CX, and you can see in lecture 29 at 8 minutes 15 seconds. And in option C it says it removes some information from the data. Yeah, some of the information about the data is being lost. uh, okay, it doesn't remove, it actually gets lost. Okay, because if we are doing compression, then some of the data gets lost. Okay, it is a lossy compression, you can say. And we are using unsupervised approach. So what actually happens is, now first it will go from the input layer to the hidden layer. Okay, hidden layer will have less number of neurons. Okay, and in hidden layer, uh, since it is having less number of neurons, so it will store more important features uh, about that particular given data set. Okay, and then from that given after extracting those informations, it will once again create the output. In the output neuron, it will create all the neurons accordingly. Okay, and then we try to match it with one another, that how much of those two values are similar with each other. The input layer and the output layer is matched with one another. Okay, so uh, we also compute the loss for it. So that's why this option is also correct. It removes some informations, like we can say that this option is also correct. Okay, in option 7, eigenvectors describe the length of the principal components. Actually, eigenvalues gives the magnitude, and we can say magnitude as the length. Okay, eigenvectors describes about the direction in which the data is present. Okay, in the plane, it could be 2D plane, 3D plane, multidimensional plane, etc. Okay, now in question 8, the single hidden and no bias encoder has 100 input neurons and 10 hidden neurons. What will be the number of parameters associated with it? Okay, so first I will show you how is the structure of the autoencoders and decoders. Okay, hello. So guys, this is the way autoencoders look like. So this is the input layer. Okay, it will have some bunch of neurons, then we will have one hidden layer. Okay, and then we will have an outer layer. So between uh, input layer and hidden layer there are certain lines drawn, and each of one will have a particular weight. Okay, the parameter, you can see that every node of input layer or neuron of input layer is connected with every neuron of hidden layer. Okay, you can also see that the total number of input layers are equivalent to total number of output layers. Okay, so what will actually happen is that we will provide an x data from here, then it will shrink the value and store it, and then it will regenerate, it will try to regenerate. That's why w1 apostrophe is written over here. Okay, which will do the reverse job of w1. Okay, so it will create once again, and it is considered to be x cap, and then we try to figure it out, like how much data is lost. So we do it in the same manner of mean square, sum of mean square error. Okay, in this way. So this is how the autoencoder works. In the work of in the usage of deep learning, the decoding part from hidden layer to outer layer, decoding part is there, and input layer and hidden layer encoding part is there. So encoding part is used, decoding part is not used. Okay, so I will share one more thing. So these are represented in this manner. Okay, encoder and decoder, so that people don't get confused with the encoder and decoder with other deep learning other networks. Over here you can see one image is shown. Okay, okay, so this image that is created over here na, this image is created in the hidden layer, bottleneck layer. So what is happening is that total number of pixels are provided from x as an x input. Okay, and then this this image is created inside bottleneck hidden layer. Okay, from this it once again try to generate uh, that particular image in the output layer. Okay, in this way it is working. Okay, now uh, since the input neurons 100 is given, 100 input neurons are given. Okay, so we can also say that 100 input neurons will be present in the outermost layer also. Okay, so 100 and in between we have one hidden neuron which will have one hidden layer which will have 10 neurons. Okay, so 100 and 10, so between them how many parameters will be there? 100 into 10. Then from 10 to 100, like from hidden layer to outer layer, so it will be 10 into 100. Okay, so 100 into 10 plus 10 into 100 is equals to 2000, so B option. Okay, now in this question, which of the following two factors can form the first two principal components? Okay, in this question, as I told you that the principal components that are formed now, that are orthogonal to each other. You may remember that in question 3 I told that it is orthogonal linear combination. Okay, so all the vectors na are perpendicular to one another. Okay, so we just have to find 2 points that are perpendicular to one another from origin. Okay, so what we can do is we can use dot product. What was the formula of dot product? That was a dot b is equals to magnitude of a into magnitude of b cos theta. Okay, we can remove a magnitude of a magnitude of b because cos 90 is equals to 0, so this whole value will be 0. We won't care about a and b. Okay, because whatever the number is coming from a and b na, multiplied with 0 will be 0. Okay, so what I did is that yeah, and dot products formula is xa into xb plus ya into yb plus za into zb plus etc. Like as many points are there. For example, there were 4 points now, so fourth point of x and the fourth point of y, fourth point of a and fourth point of b are multiplied together and then added with this series. Okay, so sum will be 0. So I have added the point for option A. 2, this 2, this one 2, this 2 and this 3 are multiplied. Then this 3 and this 1 is multiplied. This 1 and this minus 9 is multiplied. So the sum is 0. So option A is correct. I haven't checked for B, C and D, so you guys can check. Okay, so in the 10th question it is saying that let's say vectors a 2 4 and vector b n 1 forms the first two principal components after applying PCA. Under such circumstances, which among the following can be the possible value of 1? Okay, so once again the same approach we can apply what we applied for question 9. Okay, so the dot product we are using, and we know that for perpendicular we need it to be equivalent to 0. So 2 into n, this 2 into n plus this 4 into 1, so 2 into n plus 4 is equals to 0. So n is minus 2, so option B, this one. So in this way I have solved the problems. And actually sorry that I posted this video a little late because I was having an exam today. However, I was not able to give this exam because of such a silly mistake I did. But okay, I was preparing for this exam. Heck with Infi. Okay. Hey guys, I'm also creating one WhatsApp group, so we can discuss over there also if you wish. So I will provide that link to that WhatsApp group on in the description below or in the comment section. Okay, have a nice day. Have a nice night, whatever.